So we have learned how to find limits graphically. Now we're going to look at calculating limits. But to do that, there are some rules and properties that we'll have to cover. So we're going to do that now, and then we'll get into calculating our limits. So here are a few of our limit rules. The first one says that the limit of f of x plus g of x as x goes to c is equal to the limit of f of x plus the limit of g of x. In other words, if you're taking the limit of a sum of functions, all you have to do is to take the limit of the individual functions and then add. Same thing for subtraction. If you're taking the limit of the subtraction or the difference of two functions, you would take the limits individually and then subtract. Rule number 3 says that the limit of k times f of x, and k here is a constant, so k is a real number. So if you're taking the limit of a constant times a function of x, what you can do is to factor out the constant, take the limit of the function alone, and then multiply by the constant. Or number 4, the limit of a product of two functions now, right? The limit of f of x times g of x. Again, just like 1 and 2, you can take the individual limit. So you would take the limit of f of x, take the limit of g of x, and then multiply. Rule 5 is for the limit of a quotient. So if you're dividing f of x by g of x, and you're taking this limit as x goes to c, again, you can take the limits individually. So you would take the limit of f of x, take the limit of g of x, and then divide, right? And this rule is provided that the limit of g of x is not 0. So we don't want our denominator to be 0. Number 6 says if you're taking the limit of a function and the function is being raised to a power, what you can do is to first take the limit of the function without the power, and then after you get the limit, you would raise that value to the power. Rule number 7 is for the limit of a constant, right? So if you're taking the limit of a constant, right, k is a constant, as x goes to c, it's going to give you back the constant. So the limit of a constant is the constant itself. The final property that we need to look at before we start to calculate our limits is the limits of polynomials and rational functions. So it's saying if p of x and q of x are polynomials, then the limit of p of x as x goes to c is equal to p of c. In other words, if you're finding the limit of a polynomial as x goes to c, all you need to do is to plug in x as c into your polynomial, right? So it's just a matter of replacing x with the c value here. Number 2 is saying if you're finding the limit of a rational function now, right, which you know is polynomial over polynomial, all you need to do is to do the same thing. Plug in x as c. So it would be p of c divided by q of c. Alright, let's look at some examples now of how we calculate limits using these rules and properties. So here we're taking the limit of 3x cubed minus 4x plus 8, which is a polynomial, as x goes to -1. So all we need to do to calculate the limit is to substitute in x as -1. So wherever there's an x, we're going to place -1. So this is equal to 3 times -1 cubed minus 4 times -1 plus 8. This is 3 times -1 plus 4 plus 8 and we get our limit to be 9. Let's look at a second example. The limit of 3x cubed minus 8 all over x minus 2 as x goes to 1. So this is a rational function, and according to our rule, all we need to do is to take x as 1 and substitute it into the rational function. So the limit is going to be equal to 3 times 1 cubed minus 8 divided by 1 minus 2, which is 3 minus 8 divided by negative 1, negative 5 divided by negative 1, and our limit is 5.